Hello students, how are you all? I hope you all are very fine and studying real hard, isn't it? Well, after the completion of dimensional analysis, let's start with another very interesting topic. This is the last topic of physical world and measurement, and it's error analysis. So in this particular lecture, we will discuss regarding error, the types of error, right, and how to mathematically calculate certain errors. So in this session, we will be covering these topics. Now students, before we start with the actual topic, error, we need to be familiar with certain things. We all are aware that the foundation of science in general and particularly in physics is experiment. Science itself means knowledge, to know. So the foundation of science and particularly physics is experiment. What I mean to say is that whenever some law or principle is developed or it is discovered or it is formulated, then first and foremost that law or principle has to be experimentally validated. Experimental verification of the law is a must, right? And students, think over it. Doing experiments involves various different types of physical quantities, and obviously some instruments, some devices are also used in measuring those physical quantities, right? And during experimentation, when we measure the physical quantities with the help of these instruments, then there are certain uncertainty in the measurement due to the drawbacks or due to the limitations of the instruments which we are using. So that uncertainty in the measurement is known as error. So students, error means the uncertainty in the measurement of a physical quantity by using some device or instrument. That is actually an error. Now there are various types of measuring devices. We can make use of a simple scale or a ruler. It has got 10 equal divisions, each division being equal to 1 millimeter, isn't it? So its least count is 1 millimeter. So using a ruler, we can measure accurately only up to one place of decimal. So it has this limitation. There are certain other devices which are more sensitive, which can measure accurately up to 2, 3 or even 4 places of decimal. So what I mean to say is that every instrument has got some limitations. So while using those instruments in a particular experiment, the measured values obtained suffers from some sort of uncertainty. And students, that uncertainty in the measurement of a physical quantity using instruments or devices is known as error. Right? So, there are various types of errors actually. Constant errors, systematic errors, random errors, gross errors. We'll discuss. These are theoretical portions. So, we'll discuss one by one. Let's first concentrate on the constant errors. Now look, it's pretty clear from here itself. Constant, whose magnitude, whose value doesn't change. So, after a series of observations in a particular experiment, if it happens that the observations are in error by the same amount, then that type of error is known as a constant error. For example, this is a normal scale. This is 0. It has got 10 equal divisions. 3, 4, 5, 6, 7, 8, 9, 10. This is a correct one. This is a correct one. This is a correct scale. Suppose we are making use of an instrument, that is ruler, which has got 9 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a faulty one. Now look, it has got 9 divisions. So if we use this instrument while measuring the length of any given object, then it will always show an error by the constant amount. So that error which we will obtain using this instrument time and again is known as a constant error. because whatever will be the experimental or measured value, that will be always having a constant error. That will be in error by a constant amount. So students, such errors which are having constant magnitude or the error are in constant value or constant amount, they are known as constant errors, right? Systematic errors. These are those errors which are of the same sign, either positive or negative. In the subsequent lecture, we will discuss about vernier calipers, screw gauge, their positive zero error, negative zero error, then their corrections. So if it happens that the errors are having the same sign, then they are known as systematic errors, either positive or negative. It can further be subdivided into various categories. Like there are instrumental errors. This can be also considered to be a part of systematic error only. Due to the faulty construction of the instrument, the error might happen and it will produce the error of the same sign. So that's a systematic error due to instrumental error, right? So instrumental error is a part of systematic error only. Then there are personal errors. Personal errors arises due to the personal peculiarities of the observer or the experimenter. So that is the error due to personal reasons, right? Then there are also errors due to external factors. Now this is very important. Now external factors are temperature, pressure, etc. Right? For example, we are making use of a metallic scale. Now when there is an abrupt increase in the temperature, obviously the scale will expand. So when we use that scale in measuring the length, it will obviously show some sort of error. So on increasing temperature, it will certainly show some error of the same sign. And during winter or due to the drastic decrease in the temperature, the metric scale will contract. So again, using that scale in measuring length, it will show error of different sign, right? So in a particular condition, the errors will have either positive value or negative value. So that's systematic error, right? They will have the same sign. So that's the error due to external factors or external conditions like temperature, pressure, etc. There are also some errors due to the imperfection while doing experiments. So these are the errors which comes under the category of systematic errors. Now students, random errors. They are also known as chance errors. They are also known as chance errors. They are also known as chance errors. Why they are known as chance errors? Because their sources are not known. The sources of constant errors and systematic errors are known to us, and hence appropriate corrections can be made so as to minimize those errors. But random errors are known as chance errors because their causes are unknown to us. Their causes are unknown to us. So that is the reason why they are known as random errors. I'll give you an example. Suppose we need to experimentally determine the value of a physical quantity. Its values measured in a series of observations are suppose A1, A2, A3, A4 and A5. Suppose these are the observed or the experimental values obtained in a series of observations. Now in order to minimize the error, what should we do? We should take its average value. We should take its arithmetic mean. Because the arithmetic mean of all these measured or experimental obtained values would be closest to the actual value of that physical quantity. So the true value of the physical quantity would be given by arithmetic mean of this. As students, we all are aware arithmetic mean is the sum of all the observations divided by total number of observations. Here you are considering 5 different observations, so it will be divided by 5. In case of n observations, it will be divided by n. So, in order to reduce the random errors, what we do is we take the average of or the arithmetic mean of all the observed values. So, this value is found to be the closest to the actual value of the physical quantity, right? So, that's true value. Gross errors. Students, these are the mistakes. There's a difference between error and mistakes. Gross errors are known as mistakes, right? Gross errors are known as mistakes. These errors occur due to the fault or faulty observations on the part of the experimenter. It is due to the inexperience of the experimenter. The more the experienced the experimenter is, the lesser will be the error. Suppose while writing 2.34 centimeter, while recording the value 2.34 centimeter, an observer or experimenter writes it to be 4.24 centimeter. So that's a gross negligence. So the mistake or the error which occurs as a result of negligence on the part of the experimenter or the observer, they are known as gross errors, which are actually the mistakes committed by the experimenter. And here I must again repeat that the more experienced the experimenter is, the lesser are the chances of making gross errors, right? So these are some of the errors which we have discussed. Now these are the errors which are qualitative, which we have done it qualitative study. Now there are some other errors which we can measure, and accordingly while writing the result we can express the result in terms of those errors, like absolute error, relative or fractional error, then there is a percentage error. So in the next 15-20 minutes we are going to discuss those types of errors. They are absolute error, mean absolute error, relative error, and then percentage error. So we'll discuss one by one. So let's start with absolute error. Just now we have discussed the true value of a physical quantity is the average or the arithmetic mean of the observed values, right? So let us consider a case whereby the observed values of a physical quantities are A1, A2, A3, A4 and so on, AN. Suppose. So what will be the true value? True value would be given by A bar. A bar, it suggests arithmetic mean or the average. This is the true value of the physical quantity. It will be given by A1 plus A2 plus A3 plus AN divided by N. So students, remember, that's the true value. These are the observed values in the first observation, the second observation, third, fourth and nth observation, and this is the true value. So absolute error is given by the difference between the true value of the physical quantity and the observed value. This is the formula. So absolute error is defined as the difference between the true value and the observed value. Now how to denote it? The absolute error in the first observation, it will be represented by del A1. Del, that represents small chain. So del A1 represents the absolute error in the first observation. So it will be equal to, what is the true value? A bar. Minus, what is the observed value in that particular observation? It is A1. Right? Similarly, what is the absolute error in the second observation? It will be del A2. We are dealing with the second observation, this one. So in this case again, the formula is true value minus the observed value. True value would be given by the arithmetic mean, which is A bar, minus observed value in the second observation is A2. In the third observation, the absolute error would be given by true value minus the observed or the experimental value in the third observation, that is A3. Similarly, the absolute error in the nth observation would be given by del AN. It is equal to true value, that remains same, A bar, which is the average value or arithmetic mean of all the observed values, minus the observed value in the nth observation, that is AN. So students, I hope it's pretty clear. So I repeat, absolute error is the difference between the true value and the observed or experimental value of the physical quantity under consideration. So that's absolute error. Now mean absolute error. Mean absolute error. It is actually denoted by del A bar. These are the absolute errors in the individual observations. This is for the first observation, second observation, third observation. This is for the nth observation. The absolute error is given by this. Mean of all these absolute errors, that will be known as mean absolute error. And while dealing with the mean of absolute errors, we need to take the modulus value. We need to consider only the magnitude. So this is the mean absolute error. It is defined as the mean of the mod of the absolute errors. So this is it. Del A1 plus, this is a symbol for mod, that is we are considering only the magnitude, plus del AN divided by N, and it is represented by del A bar. So what is mean absolute error, students? It is defined as the mean of the mod means magnitude of the individual absolute errors, right? Next is relative error. It is also known as fractional error. Relative error is also known as fractional error. It is defined as the ratio of the absolute error to the true value. So over here it will be, this is the true value, absolute error, mean absolute error divided by true value, that is A bar. This is known as the fractional or the relative error. So relative with respect to, right? Fractional, it is in the form of P by Q. So fractional error is defined as the ratio of the mean absolute error to the true value. Percentage error. When the fractional or relative error is multiplied by 100, then it will give us percentage error. That is, it is relative error multiplied by 100, which is del A bar divided by A bar multiplied by 100. So that's percentage error. Let me repeat and then we will discuss a very simple numerical, right? So that you will understand it completely, right? Without any sort of ambiguity. So absolute error, it is defined as the difference between the true value and the observed value. It is represented like this. These are the absolute errors for the first observation, second observation, third observation and the nth observation respectively. Mean absolute error, as the term suggests, it is the mean or the average or the arithmetic mean of the mod of the absolute errors. Relative error, it is also known as fractional error. It is defined as the ratio of the mean absolute error to the true value. Percentage error, when the relative error or fractional error is multiplied by 100, then it will give us percentage error, right? So let's discuss a very simple numerical, right? So what we'll do is, you are aware of acceleration due to gravity, isn't it? It's represented by small g. Acceleration due to gravity, it is represented by small g. In +1, using simple pendulum, we can easily determine the value of small g, right? So, suppose in a simple pendulum experiment, the observed values of acceleration due to gravity are found to be g1, suppose it is 9.7 meter per second square, g2, suppose it is 10 meter per second square, g3, suppose it is 9.9 meter per second square, g4, suppose it is 9.6 meter per second square, and g5, suppose it is 9.8 meter per second square. These are the 5 set of observations where the value of small g is found to be as shown, as written in the board, right? G1, G2, G3, G4, G5. I repeat, in an experiment of simple pendulum, the observed values of acceleration due to gravity in 5 different observations are found to be G1, G2, G3, G4 and G5, right? What we are supposed to do is, we are supposed to find the absolute error in the individual observations. We are supposed to find out the mean absolute error. We are supposed to find out the fractional error. Also, we are supposed to find out the percentage error. And lastly, we are supposed to express the result in terms of absolute error as well as percentage error. Let's see. First one, let's find out the absolute error. And before that, we need to find out the true value. What's the true value? It will be represented by G bar. This will be the true value. And students, again, let me repeat, true value will be given by the arithmetic mean of all these observed values. So, what will be the true value? It will be G1 plus G2 plus G3 plus G4 plus G5 divided by 5. Right? This will be the mean or the true value. So, it will be, you can solve it. It will be 9.8 meter per second square. So, this is the true value. You can easily solve it and you will get the answer. I have taken such value that you can solve it yourself, right? And just make use of your common sense. 9.8, it's the mid value between the other 4 given values on either side of 9.8, right? So, if you solve it, you will get this only. That you can do at your own. So, this will be the true value. Now, what to do is absolute error. Absolute error in the individual measurements, right? Del G1, it would be true value minus observed value in the first observation. So, what do you get? 9.8 minus 9.7, that is 0.1. Del G2, it will be G bar minus G2, which is true value is 9.8 minus G2 is 10. So, it will be minus 0.2. Right? Del G3, it will be equal to G bar minus G3. It will be 9.8 minus 9.9. So, it will be minus 0.1. The absolute error in the fourth observation, it will be again G bar minus G4. True value is 9.8 minus G4 is 9.6. It will be plus 0.2. And the absolute error in the fifth one, true value minus the observed value. So it is 9.8 minus 9.8. That will give us 0. So students, I hope it's clear. Absolute error in the individual observation is given by the difference between the true value and the observed value in that particular observation. So these are the absolute errors in the 5 different observations. Right? Now let's find mean absolute error. Mean absolute error. It is given by del G bar and it will be mod of del G1 plus del G2 plus, how many observations are there? 5 divided by n. Mind it, mod of means magnitude. So, del G bar, it will be equal to del G1, there is 0.1 plus minus 0.2 plus minus 0.1 plus 0.2 plus 0 divided by 5 observations. So, divided by 5. So, mod of minus 0.2 is 0.2. Mod of minus 0.1 is 0.1. So, what do you get is 0.6 divided by 5. So, that will give you 0.12. So, students, this is the mean absolute error. Mean absolute error in the determination of the value of small g. Right? Okay. Fourth one. Let's find out relative error. Relative error or fractional error. So, what's the formula? Mean absolute error divided by the true value. So, it will be 0.12 divided by 9.8. That can be easily solved. So, that will give you the result. This will be the relative or the fractional error. Right? This you can easily solve. Fifth one, percentage error. it is given by relative error multiplied by 100. So it is 0.12 divided by 9.8 multiplied by 100. So this will be the percentage error. This is the percentage error. Let us assume its value is x and its value is y. X and y can be easily determined, right? So how to express the result? How to express the result in terms of absolute error and percentage error, right? So what to do is, we will represent the value of acceleration due to gravity in terms of absolute error and percentage error. So how to write the result? So acceleration due to gravity is given by true value. This is the true value plus minus mean absolute error. This is the proper way of writing it. So how to express the result? It would be 9.8. This was the true value of acceleration due to gravity plus minus. What is the mean absolute error? That is 0.1. 0.12. And units would be in meter per second square. And if you wish to write it in form of percentage error, then it will be 9.8 plus minus. This is the mean absolute error. This is the true value multiplied by 100, which we get y. From this, you can substitute the value of percentage error over here, right? So this is the proper way of writing it. What it means is that the value small g can vary between this to that range. Its value will vary from 9.8 minus 0.12 to 9.8 plus 0.12. So the value of small g may vary from this lower limit to that maximum limit. Clear? So this was a simple illustration so as to make you understand regarding the types of errors. Basically, absolute error, mean absolute error, fractional or relative error, and lastly, percentage error. So students, I hope you have understood this theoretical concept completely. And in the next session, we will discuss the topic of propagation of errors, where two quantities, when they are added or subtracted or any mathematical operation is involved, either multiplication or quotient, then how the errors are combined, how the errors are propagated. So that topic we will discuss in the next section, right? Anyways, do take care of yourself, and if you like the way of my teaching, then do subscribe my channel, right? So that you will receive the notifications whenever I upload a relevant video concerning your class. Okay, thank you students.